Good afternoon, everyone. Welcome to the Rumelhart Prize reception, presentation. I'm sorry, anticipating a drink later on. My name's Kenny Smith. I'm the chair of the Society. We're about to do an iterated round of introductions, actually a hierarchically nested iterated introductions, which I'm kind of into. I get to kick off this year's installment by introducing Robert J. Glushko, Bob Glushko. The most important thing to know in this context is that Bob was a student of Dave Rumelhart at UCSD. Bob's going to say more about Dave Rumelhart and his motivation for establishing this prize in a moment. What I'm going to do is tell you a little bit about Bob, and then I'm going to hopefully embarrass him by telling you some of the things he's done for the Cognitive Science Society. So Bob completed his PhD on statistical properties in reading aloud in 1979, and then he went into industry research and development, working initially at Bell Labs, where he helped invent ebooks and document management. In the 90s, he co-founded several companies in Silicon Valley, including one company that helped other companies become digital publishers, and one company which pioneered what we would call these days web services, and also the use of XML for business transactions. He then retired to Berkeley as an adjunct professor in 2002, retired definitely in scarce quotes. After his retirement, he wrote 2 books, Document Engineering and The Discipline of Organizing, which was the Information Science Book of the Year in 2014. So what that rather dry summary doesn't really capture is Bob's passion for cognitive science, which really shines through if you speak to him in person. He has a passion for cognitive science, both as a cognitive scientist. He's made his contribution to the empirical basis of our field, and he has a passion for cognitive science as an advocate for CogSci as a scientific endeavor. Bob has been incredibly generous in supporting the Cognitive Science Society. Over the course of several decades, he's made direct contributions to the financial security of the society in times of difficulty, which are hopefully quite far in the past now. He has sponsored the Glushko Dissertation Prizes. He sponsored the Glushko Travel Awards. He established and made a substantial contribution to the Elman Prize Fund. And he is funding the Rumelhart Prize that we're here for today. So as I hand over to Bob to make the next set of introductions, I want you to join me in thanking him for his contribution to cognitive science and the society.
This was very too flattering, but since I've been often introduced as a celebrity philanthropist, it's nice to know I have a professional biography. Now, I've talked about the Rumelhart Prize for 21 years since we started in 2000. And I say the same things every year, but that's important because what's really great about this field is that it keeps growing and growing with new people. So this year, out of the 600 people who were in this room, 200 of you were here for the first time. I know this for a fact because we ran out of the new kid badges really fast. And people said, well, where's my badge? We ran out of the first 150 the first half day. So I have to tell you the story because you've never heard it. So we created this prize to remember and honor David Rumelhart for his many contributions to cognitive science. In the 1980s and 1990s, Rumelhart did much of the foundational work on neural network models, including backpropagation and other learning mechanisms that are built into today's AI foundations. And many of the names you commonly associate today with important work in these areas, James McCullen, Jeff Elman, Jeff Hinton, Michael Jordan, Paul Smolensky, so on and so on, all of whom were Rumelhart Prize winners, by the way. We're all students, postdocs, or collaborators with David Rumelhart. Now, in addition to his work on learning, Rumelhart made important contributions in word recognition, reading, story grammars, and motor control, and he would have made many more, but he was struck down in his prime by a crippling brain disease. So we should remember Rumelhart for his research contributions alone, but I also remember him as a very decent and generous person. He always had time for students and colleagues, giving them ideas for research and their lives, and at times even helping them in atypical ways. I mean, I remember as a graduate student at UC San Diego in the 1970s, asking Dave a question or something, and then finding in my office notes on my whiteboard the next morning. He wrote code to help me analyze my dissertation. I mean, how many of you have written code for your, for your graduate students, of the professors here, right? Probably not many. So these characteristics which Rumelhart embodied are the criteria for which we select the recipients of the Rumelhart Prize. They need to be a great scientist, but they must also be a scientific and personal role model. The kind of scientist we should, and a person we should all aspire to be. So that's why every recipient of the prize, 22 so far, has not only made important contributions to cognitive science, and they're deservedly being honored by the prize, they've also brought honor to the prize and reinforced cognitive science as an important scientific discipline. Now, it's been a tradition at this point for the previous recipient of the prize to introduce this year's recipient. But before that introduction, we have a makeup ceremony because last year's recipient got her medal in Zoom space. And so we'd rather do it here in physical land. And so I'd like to have Susan Golden Meadow come up and be awarded the 2021 prize and Nobel Prize and prize. Yeah, no. And now I think it's Susan Golden Meadow's great privilege to introduce Mike Tomasello.
Sort of choking me a little. Okay, it's a pleasure to introduce Mike Tomasello. Mike began his illustrious career in the 1980s as a professor of psychology and anthropology at Emory University. His work at that time focused on language acquisition in children, but he managed to sneak over to the nearby Yerkes National Primate Research Center, where he found and started thinking about non-human primates. And that move set the course of Mike's research agenda. In 1988, he became co-director of the Max Planck Institute for Evolutionary Anthropology in Leipzig, and later also honorary professor at the University of Leipzig and co-director of the Wolfgang Köhler Primate Research Center. In 2016, he came back to the United States to become professor of psychology and neuroscience at Duke University, where he is now the James F. Bonk Distinguished Professor. Mike has received more honors than you can count, so I am obviously not going to list them all, but I'm going to give you a few. The Royal Netherlands Academy of Arts and Sciences Heineken Prize for Cognitive Science in 2010, the British Academy's Wiley Prize in Psychology in 2011, and the American Psychological Association's Distinguished Scientific Contribution Award in 2015, and now, of course, the best, the Rumelhart Prize. He was also elected to the American Academy of Arts and Sciences and to the National Academy of Sciences in 2017. So the question is, how do humans differ from other great apes in cognition and sociality? Mike's studies on the psychological processes of social cognition, social learning, cooperation, and communication have shed light on human uniqueness, as well as on the cognitive abilities of our closest ape relatives. He finds that chimpanzees and children have similar physical world-related cognitive skills, but the children have more sophisticated social abilities than non-human primates. Apes and humans understand others as animate, goal-directed, and intentional agents, but only humans are motivated to share emotions, experiences, and activities with others. For example, chimpanzees gesture, but their gestures are not aimed at establishing joint attention with other chimps or with humans. In contrast, human gesture and human language both have this goal. This uniquely human ability develops gradually during the first 14 months of life. Mike has argued that only one known mechanism could bring about the changes separating human beings from other great apes: social or cultural transmission, which works on timescales many orders of magnitude faster than those of organic evolution. He has hypothesized that a crucial difference between cognition in humans and cognition in other species is shared intentionality, the ability to participate with others in collaborative activities with shared goals and intentions. Shared intentionality, which is fundamentally about cooperating in everything from taking a walk together to creating a social institution, provides a powerful theoretical framework for unifying the differences Mike finds between great apes and human children across many psychological domains. So Mike has explored humanity's uniqueness in a trilogy of recent books: A Natural History of Human Thinking in 2014, A Natural History of Human Morality in 2016, and Becoming Human, A Theory of Ontogeny in 2018. In the third book, he uses his decades of experimental studies on non-human primates and children to identify 8 pathways that differentiate humans from great apes: social cognition, communication, cultural learning, cooperative thinking, collaboration, pro-sociality, social norms, and moral identity. So I don't know whether we'll hear about all 8 today, but I can promise you an exciting and far-reaching talk. Please join me in congratulating Mike Tomasello on winning the Rumelhart Prize and in welcoming him to cognitive science.
So now, it's my great pleasure to give Mike Tomasello a check for $100,000.
Dinner's on me.
And a very heavy bronze medal with Dave Rumelhart on it. So congratulations. All right. All right, good. All right, I'm going down here.
Okay, good. Thank you. This is, well, gosh, we, none of us do any of this expecting something like this. I didn't know about nominations. Just all of a sudden I get an email and say, you won the lottery. So, oh, my lottery fell out on the floor here. Sorry. So anyway, I, like everyone else, am greatly appreciative of Bob for all he's done to support the Cognitive Science Society. And I'm so grateful for this award. I appreciate it very much, and I look forward to sharing some of my more recent research with you today. So as Susan said, I have focused a lot on differences between humans and great apes. But in the animal world, where we publish a lot of our great ape papers, there's still a lot of people talking about stimuli and responses and stuff like that. There's still some behavioristic overtones in a lot of the animal research. We get reviews back on our papers that clearly are from sort of behaviorist people who said, what are you doing attributing cognitive processes to animals? And so in any case, I wrote a book. I'm going to tell you about it today. And I would say the strategy is one that is tried and true in cognitive science in general, and that is building up from the simple to the complex. And I know that people do that in modeling, in artificial life, all kinds of things start with the simple, and then we're going to build up to the more complex. But in natural phenomena, in humans, the two main ones are, of course, ontogeny or development, which is well represented at this society, and phylogeny or evolution, which is not as well represented. And so I want to talk about evolution, and I want to go back further than Susan mentioned, but before apes, and let's look at what characterizes the evolution of cognitive abilities going way back. All right, and that's what I want to do today, and I'll end with a little bit on humans. So the first principle in the evolution of psychology and cognition is that natural selection can see only actions and their physical implementations. It can't see cognition or emotions. If you can be as smart as you want to be, but if you can't translate it into action, then natural selection cannot do anything about it. Okay, so it needs to translate into action. These are pictures of Darwin's famous finches on the Galapagos Islands, where their beaks are differently shaped so that they can do different things, so that they can forage for different insects or seeds or whatever, right? So starting from this fundamental insight, I want to look at how organisms organize their behavior. So this is the new book, Evolution of Agency, Behavioral Organization, from lizards to humans. I'll get that. So going back a little further than is my normal way. And I want to distinguish cognitive content, all the myriad behavioral adaptations, our vision, memory, whatever, all the different things that different animals do. Squirrels caching nuts, bees having beehives, all those are specific adaptations with cognitive content. But there's also the cognitive organization, and this is why it relates to the behavior. This is why it's important for the notion that behavior is the driver of everything, is that there is also a cognitive organization for behavioral decision-making. Cognition is in the service of behavioral decision-making in evolution. Now, we humans can do lots of other things, but in the evolution, it was always tied to an adaptive problem that you solve behaviorally, and cognition was part of the solution. And notice this cognitive organization, focus on that, is different from the focus in the classic evolutionary psychology of Tooby and Cosmides and colleagues, which is very much focused on very specific things. Here I'm talking about very general decision-making capabilities. So you can divide this organizational dimension of things, and you can make a very gross cut in two kinds of organization. One is stimulus-driven, and this is reflexes and things like that, which does indeed have a stimulus response kind of organization. But that's not what intelligent, active creatures are doing. They're pursuing their goals and trying to figure out how things work so they can meet their goals. So in this book, I developed the idea of agency. And by agency, I mean decision-making. And I would claim that many creatures, I'm going to claim at least all vertebrates, do make behavioral decisions. Now, I'm not talking about philosophical free will or something. What I'm talking about is, let's imagine a squirrel. Squirrels are adapted, they're hardwired for caching nuts. But now a particular squirrel on a particular occasion is viewing a landscape, and that squirrel has to make the decision about where to cache that nut right now. Biology could not have prepared the squirrel for this decision. It's within the structure, the inherited structure, the things they perceive, the way they see the layout of the space, the way they discriminate different locations, all of that can be part of the hard wiring. But still, the agentive part is making a decision at this moment where to cache this nut. So that's what I want to say about agency. Making, the individual makes the choice, not biology makes the choice. And my model, of course, is the very simple. I just have up here your classic thermostat, has been the classic example all the way back to the early cyberneticians of a control system that pursues goals and senses the environment and acts in a way that your perception of the environment matches your goal. You want the world to be a certain way, and you act until it is that way, and then you've met your goal. So I'm using just a very, I mean, for people like you guys, this is just a overly simplistic model, but it's going to help us because we're going to start with lizards. And lizards are not as complicated as human beings, in case you hadn't noticed. And I do want to mention, I do want to take note, you ask, well, why do organisms develop this way? And the proposal is that evolve to deal with uncertainties. So you have these, amoebas and all kinds of invertebrates, filter feeders, they swim around in bacteria and open their mouth and the bacteria come in. They don't have a lot of decisions to make. They are built to survive by just moving around randomly and soaking stuff up. All right. But what happened at some point in evolution is that animals started needing to deal with more unpredictable situations, and their stimulus response won't work. Hardwiring won't work. All right. So what I'm going to do is I'm going to go through very, very, very briefly the earliest vertebrates and the earliest vertebrates, land vertebrates, sorry, we're excluding fish here. The earliest land vertebrates were lizard-like, according to the literature. The earliest mammals were squirrel-like, according to the literature, and rats are close enough, so we can use that literature. And great apes, current great apes are close to the earliest great apes, not the earliest primates, the earliest great apes. And then we've got some early humans. So this is not a scala natura, but it's a historical sequence. This sequence happened. Vertebrates led to mammals, mammals led to apes, apes led to humans. Oh gosh, sorry, I had a fat finger there. Okay, and there's nothing mysterious about this. People are very worried about, scale, oh, it all builds up to humans at the top. That's not me. This is just a historical sequence that led to us. You could do other historical sequences to the social insects, to everybody else. This just happens to be the one, since I'm interested in humans, the one that leads to humans. And the evolution of complexity is a really interesting literature, talking about why there is this increase in complexity over evolution in some lines. Having to do with decreasing in complexity often leads to more issues and increase. So anyway, I'll leave that aside. And so we're using these creatures, none of these creatures exist. So what we're doing is we are using model species that currently exist so that we can make some guesses about what their behavior is like. So our model species are going to be lizards, squirrels, great apes, and young children, which are going to be not exactly like early humans, but share some features. Okay, so goal-directed agency. These are the earliest land vertebrates, and they are basically a control system, a straight control system. The unpredictabilities was insects. So I left fish aside because there's not very much research on them, but fish probably do some things too. But in any case, they had to start feeding on insects, and insects are quite lively and quite strategic and escape and fly and go under rocks and whatever. So they had to come up with something better than stimulus response. Right? And so again, it probably goes back a little bit before, but these guys are going to end up needing to have their behavior organized as goal directed with some kind of flexibility to do what they need to do to survive and thrive. Now, in reviewing the behavioral literature on lizards, which was quite fun, I had never gone back quite that far before. There's a nice behavioral literature on lizards, and I believe that it suggests they only make go, no-go decisions. So it's like a thermostat, right? A thermostat either turns on or off. That's it, right? And a thermostat turns the heating on or off. They are looking and saying, is that a good foraging location? Yes or no? Should I attack now? Yes or no? Should I do this? Yes or no? So they go from a sequence of yes, no decisions, one after the other. That's what the literature suggests to me. And they don't really have any executive function. And this is going to be key to my story. They do have something like global inhibition. That's a word that's used in the neuroscience literature. That is, if the predator's coming, they stop, they freeze, and then they do something else. So there's a shutdown of the system is the only thing that you'd want to call executive function, but that's not what we're going to focus on in a minute, which is proactive executive functioning. And finally, let me point this out. This is something that I've gone all the way back to my 2014 book on the evolution of human thinking. I think it's really important that we're not talking about perception. Once you have a goal-directed organism, you're talking about attention. When they're pursuing their goals, when you're pursuing your goal, when I'm pursuing my goal, I don't focus on the color of the ceiling or the temperature of the room. I focus on things relevant to my goals. Right? So, and things that are, and basically relevant situations. Okay, there's a predator nearby. That thing is ripe to eat. I won't be able to leap that high. So these are situations, and they're basically can be classified into obstacles to goal pursuit or opportunities for goal pursuit. Now, I understand there's bottom-up attention, and that would be they're just sitting there and there's some loud noise or something, and they obviously are going to tend to that. But I've conceptualized bottom-up attention as nature's way of, nature thinks it's relevant. Nature thinks it's relevant if there's a sound behind you, right? And so nature has built you to pay attention to that. So I kind of think of bottom-up attention as also relevant to goals. These are the ones that nature has for you, like surviving. And I do want to recognize that things are much, much more complicated when the lizard goes hunting, goes foraging. You know, if his stomach is full, then he doesn't, and then he spots something, and then he, you know, walks over to it, and then he, you know, attacks it and whatever, and then when he's full, all right. So it's a series of control systems. It's not one, and each one of these control systems is hierarchically organized, so that moving over to where the insects are requires moving your limbs and all that. So there are several control systems, and each of them has multiple layers. I'm just focusing right now on the major decision-making level of making decisions about whether to chase this this prey or not. All right, so the big move in mammals, if you look at the behavioral literature, is that mammals seem to be operating with some proactive executive processes. And by that, I mean they can simulate or simulate what might happen if I do this. So they're making either or decisions. They're making either or decisions, and they're imagining the outcomes before they act. So imagine a squirrel is sitting here on a limb, and they're deciding, can I leap over there, or should I go over here? Should I go down, or should I leap? And they are actually deciding. There's very nice literature showing, and they even have a behavioral thing. They look like this in discrimination tests. They look like this when the discrimination gets hard. Rats do something similar. And I think the evolutionary context is one of competition, social competition. Lizards are mainly solitary species. They're born in eggs. They come out, they do their thing. They live in these burrows with some other guys, but they're not social really. And with mammals, you get social competition. So it's not necessarily that you have a theory of mind of your competition, but you've got to be good at foraging to get it faster and better than your competition. So an executive level allows you to plan. So I would say that squirrels, based on literature, they form action plans before they act. And they choose them by simulating. So this is basically thinking. And I believe that mammals all engage in something like that. You can define thinking linguistically or in some higher way, but at its basics, it is simulating the world before you actually act, making a model of the world and simulating what might happen in it before you actually act. Okay, and in terms of the more inhibitory things, it's not just a global inhibition, but when you're making either or decisions, I think in the literature, some people talk about value-based decisions. This one's better than that one for pursuing my goal. And so now when they're choosing between them, it's what I call inhibitory control, where you're now inhibiting the less attractive alternative, and you're emphasizing the one that's more attractive. So it's a much more flexible inhibitory control rather than just some kind of shutdown or inhibit. Inhibitory control helps you settle on a decision and execute it without interference from the thing you didn't choose. Right? So it's basically the same control system architecture with proactive executive processes on top of it. Now, I will say that in formulating this way of thinking about things, I believe that the executive function literature and the cognitive control literatures are so terminologically challenging, and I stayed away from the terminology because it's all kind of loaded. A lot of things that happen here, it's called quite often proactive cognitive control, proactive executive function. But a lot of what happens here is working memory. But working memory is studied in a certain way and has certain connotations, and there's a lot of focus on limits and all kinds of other things. So I want to say just a proactive executive control. Now we get to apes, and this is something where that I actually really know something about. The lizards and squirrels I had to read up myself. Great apes, I believe, are rational agents. Now, rational is a term that means a lot of different things, and so I'm going to spell that out for you here in just a second. But I believe that requires a second executive layer. Now, that second executive layer is somewhat similar to what people call metacognition. But again, metacognition, people are always focusing on, do they know what they know and all that sort of thing, which is all absolutely part of it. But I want to focus on the behavioral control part of it, that before they make a decision, they're reflecting on this simulation of alternatives and seeing if maybe there's something better. And even after they make a choice, they can reflect on it. I'm going to show you an experiment just in a second and change their choice. All right. So, so they have a level of reflective level of executive control. So now we have the basic control system, first executive level, and a second one I'm calling a reflective level, but it's a second executive level. And I do want to point out that in this book, for the first time, I spell out the hypothesis that I believe in evolution, understanding other minds came from this metacognitive level of reflection on your own. So this is, yes, this is a version of simulation theory. I don't go into all the, I don't buy all the stuff that goes with simulation theory, but I do think that there's no other really good alternative. They're reflecting on their own decision-making process. He's thinking, okay, I'm trying this, I'm trying that, and I'm making a decision here. Won't go into all the details, but I believe that because they are good at social learning and they are adapted for social learning, where you have to match yourself to the other person. He's doing this. If I want to be successful like him, I have to do that too. That matching somehow combines with their metacognitive reflection on their own activities, and they see, oh, if I have them, then he's probably got them. So I spell that out here. So this reflective level not only leads to more rational decision making, but also it led to the first mind reading or theory of mind or whatever you want to call it. I'm leaving out other primates because the data are not clear. It may be other primates also, but with great apes, I'm quite confident. And we even have a study that back from 2015, where the ape looks through a screen. It's like the screen door screen, and they look through the screen and they see some food in a box. And I'm not going to tell you the whole methodology, but they see it. And now they're competing with another guy for food. And the other guy comes up, another chimp comes up, and looks in that box as well as some other places. And from the chimp's perspective right now, the screen is like this. And so they can't see in the box at all. But when they see the other guy looking in the box through the screen, they know that he sees it. And their competition strategies reflect the fact that they know that he's seen it. So they are, the only way they can know that he sees it is by, we have a control condition with an opaque screen, and they don't think, if it's an opaque screen, they don't think that he can see it. But if it's this screen, so they know they could see through the screen, and so he can see through the screen. Okay, and again, we had various control conditions like the opaque top and stuff like that. Right, so I believe they are attributing this. You need a metacognitive level to be able to experience your own executive decision-making and thinking, and then you need some other adaptation for matching the other guy, and then you can attribute to them. So that's that's what I think differentiates great apes and potentially other primates from other mammals. Now, here's an experiment. This is going to show you what I mean by reflecting on your decisions, and also it's going to segue into the difference with human children. So here's the study. The apes see number one on the left, and they see that the piece of food on the left is the larger one. And so they make a choice, and this is important. They make a choice. They reach out. That's their way of communicating to the human. They reach out for that larger piece. They don't get anything. But before they get anything, boom, it switches to number 2, and we have some magnifying and minimizing lenses. We are tricking them, and now the one on the right looks larger. Now, what's the measure? Well, the measure is not which one they choose. Either one is plausible, but the measure is what they do is they crawl up on the cage and look down from the top. They know from the sort of pretest, they know that the top is open and that they can look down in there and see which one. So they double check on their decision. So they get, it's belief revision if you want. They are checking to give it get more information before they make a decision. So this is not just your classic opt-out paradigm where the animal knows that they're uncertain about something. This is knowing they're uncertain and going to fix the uncertainty by getting just the information you need to fix it. Right? So I'm calling that rational because they're reflecting on their own belief about a situation and their own decision that they've already made, and they're revising it in the light of new evidence. And then what gives us the segue to human children is, human 5-year-olds did the same thing here. 3-year-olds didn't, by the way. And then in the second study, we did something similar where the ape saw where the food was, saw where the bigger piece of food was here, and then it was slid across to another ape, or in the case of children, a child saw it and it was slid across to the other child. And that other ape, we fixed it, it's rigged. The other ape chose the other box. They didn't get it, but they were reaching and trying to choose the other box. We had it rigged so they would do that. And then it comes back, and the 3-year-old children, having seen somebody else choose the other one, they crawl up on the thing and they look, gosh, you know, I thought it was there, he thought it was there, I wonder which one it is. The apes couldn't care less what the other guy did. They stuck with the way they saw it before. They did not process what the other guy did at all. So they can reflect on their own thinking, but when they see somebody else do it, they don't sort of think that as relevant to their own activity. So here's what I think happened with early humans. Now, I have used the term shared intentionality. That's the term also that Susan used, and I still use it. But in this context, I wanted to make it continuous with these other creatures. I just called the same thing shared agency, where shared agency focuses on the behavioral part and the decision-making part, and shared intentionality tends to focus on the more cognitive part. So they're the same thing. And what happened with humans, as I've proposed in several places, and the books that two of the books that Susan emphasized, is that first of all, about 500,000 years ago, humans started collaborating in new ways. And these new ways are described by what philosophers of action call shared intentionality. We have a shared goal. We're committed to it. If you don't do your part, I say, hey, what are you doing? You say, oh, I'm sorry. So, and you make excuses if you don't do your part. That's this whole normative engagement about that. So chimps don't apologize. The chimps don't make excuses. Right? They don't feel a commitment. All right, so they're not engaging in the same way. They engage in a kind of a group hunting of monkeys, but it's kind of everybody for themselves. There is some coordination. They're reacting to one another, but it's not we are hunting the monkey and you know, we owe it to one another to play our roles well, and then we're going to share the spoils at the end. No, doesn't work. But that's what human hunter-gatherers do. Everything is collaborative hunting, sharing the spoils at the end, committed to playing your role so the team can win, etc. And then a second step, about 100,000 years ago, maybe 200, is collective agency, where we really get cultures. And now we're in all these group-minded things, conventions, norms, institutions, and stuff. And this is modern humans. And this is now group-minded collaboration. We in this group, this is the way we do things. And if somebody doesn't do it, then we enforce the social norm and say, you know, don't throw your litter in my yard or in somebody else in the public space. I won't dare to look at this. I'm sorry, I apologize for this other diagram here, but I tried to make it consistent with the other ones. And the basic idea is this. We humans retain our individual agency where we decide whether we want to collaborate or not. And as the collaboration's going, we decide, oh, maybe I don't want to do it. So that's a decision. But once we're collaborating and once we're committed, then we have another sort of agency. We have the shared agency at work. And in that shared agency, we have to play our individual role. So we decided to go hunting for antelope, and that means I have to do this and you have to do that. And we each play our role. All right, so our decision-making works on 2 or 3 levels, depending how you think about it, of the individual one and the one with the group that we're in. Now you say, oh gosh, in culture, you can't just opt out. Well, you can. I mean, you can't really. That's the point. You're born into a culture and there you are. But in theory, you could opt out and go live on a desert island or something. In theory, you could be uncooperative. If you're a hunter-gatherer, you could be uncooperative. They'd kick you out of the group because you're not being cooperative. So you always have your individual agency, but once you commit to a shared agency, now you've got this complicated thing going on. The whole time you're trying to coordinate with the other person, you also have the possibility of opting out. Okay, so that's part of why human decision-making is so complicated. Some of the uniquely human things that we're getting from shared agencies and shared intentionality, I'm just going to list a bunch of them out here. I've published lots of things with these things in there. Joint attention and common ground. We get shared realities and the coordination of individuals in that shared reality. So we are all together doing something, and that leads to the idea of roles. You have your role, I have my role, and you have your perspective, and I have my perspective in this common shared reality. We get role-based concepts. Grammar is based, language is based on roles and the relationship of roles to one another, agents and patients, etc. Narratives have protagonists who do this and they play their role in the story and so forth. Right. So we get roles and perspectives. I believe that chimpanzees do not have the notion of roles or perspectives. They aren't doing something together such that you're playing your role and I'm playing my role, etc. I don't think you say they have a perspective, but if you don't have something in common, if you don't have joint attention, we're jointly attending to this. I see this side and you see that side. But if you're looking out that window and I'm looking out that window, we just see different things. The notion of perspective, I'm proposing a definition. The notion of perspective is that it's 2 different ways of looking at the same thing. So they don't have that, and they don't have 2 different roles in the same activity. Okay. Mentally recursive inferences, cooperative communication comes out of this, pointing and gestures, as Susan mentioned, I've focused on a lot. So something before language, of course, language is a whole different thing than what apes are doing, but apes have the possibility of doing, and they do produce some gestures. But we, as Susan said, we do them to share attention with other people, to share emotions with other people and so forth. But the way we do that rests on kind of Gricean communicative inferences, right? So I direct your attention over there like this. You look over there and you say, what does he want me to think? So you've got a thinking embedded in a wanting. If you go the Gricean route, you have 4 embeddings, but I'm going to leave those out. I think that the kind of inferential communication that we engage in requires socially recursive inferences, and great apes do not do those. Right? They do these gestures that basically tell the other guy, do this, do this, do this, but they're not. As Sperber and Wilson in the relevance theory, I think have the best analysis of it, that when I point over there for you, right, and let's say we have no context and I go like that, you say, why does he want, why does he want me to look over there? What does he think is relevant for me over there? And then ultimately we get to conventions, norms, and institutions, including linguistic symbols that are conventions, constructions, which are conventions. Del Goldberg has taught us all. They are also conventions with meaning. And ultimately we get to objective and normative thoughts and attitudes, what we ought to believe based on the evidence and based on arguing with other people, based on rational principles and so forth, and normative ways of treating others, how we ought to treat others socio-morally. So I would say all of the great apes share with us most of what cognitive scientists study, I would say probably, maybe, all right, if you ruled out language and took the rest of it, you know, their perception and memory and problem solving and causal understanding and the basics of reading intentions of other people and all kinds of, they're doing all kinds of intelligent problem solving and behaving, but these kinds of things they're not doing, and they're not doing them because they're not engaging with others in the way that we do in collaboration and culture. The short way of talking about these 2 things is collaboration and culture. Okay, Susan also kindly pointed out, I really look at this ontogenetically, and those two adaptations, the collaboration and culture, I think the first one begins at around 9 months. I've talked about the 9-month revolution, joint intentionality, and the second one is around 3 years, group-mindedness, collective intentionality. So I use the term shared intentionality for the whole thing. Joint intentionality is this collaborative part where individuals collaborate, and collective intentionality is the cultural group part, these group things like conventions, norms, and institutions. And Susan even elaborated for you the 8 different domains. And each of these domains, I look at what apes do, what happens to children at 9 months, and what happens to children at 3 years. And so the ontogenetic pathway goes from a kind of a general great ape baseline, and then the first collaboration, and then culture, or joint intentionality and collective intentionality. And each domain shows this. And I'm just going to very quickly, don't want to hold everybody up too long here. We got a reception to go to. But I just want to give you a feeling. People who've seen me give talks before know I like giving cute videos of kids and chimps. You know, it's always audience pleasers. So I just want to give you a feeling of the 9-month revolution. And I apologize, 2 of these are home videos. Okay, so on the left is my daughter on her 9-month day, her 9-month birthday to the day. And I thought, let's try some of these things, okay? So my wife's holding the camera. And I apologize because I get kind of excited because it's her 9-month birthday and she's having a revolution right in front of my eyes. Right? But all I want to do is roll the ball back and forth. And you can see what we do here. I roll it to her. Now watch where she's looking. This is important. She does manage to roll it back in a kind of awkward way, but she looks up to my face. And then she rolls it back again. And I'm just saying, oh my goodness, we're collaborating. What can I say? And she rolls it back and I'm so excited. And now and looks to the face. She's looking to the face because we're sharing this. She wants to see how I'm reacting to it. She says, we're doing, oh, wow, isn't this cool? All right. And we are doing that together. Chimpanzees can't do this. Right? If they were to sort of hit a ball and roll it over towards you, they wouldn't look at you like this and come back and take turns back and forth. They're just not built to do it. And these little guys, chimpanzees are so much more competent than a 9-month-old. They can climb trees, they can kill prey, they can fish for termites. They are so much more competent at life. But this little critter is still in its diapers and not even walking yet, is doing this new thing because they're adapted for this. Now, the bottom one is I was saying, look, isn't this cool? Here is look, isn't this cool personified. This is a very quick gesture, but watch. What is the motivation here? That's it. Kids do this all the time. Showing. It's the first sort of uniquely human communication is showing. Pointing is similar, but I gloss this motivation is, isn't this cool? And you're supposed to say, yeah, cool, great, right. And that's it. And you say, oh, isn't that cute? This is what little 1-year-olds do. You know, it's nice that we outgrow that. We don't outgrow that. Okay. What we do all day, every day is we gossip. And gossip is essentially, isn't this cool? Did you hear who's dating who? Did you hear who won the game last night? Did you see Donald Trump on TV last night? Whatever it is. And all we want is for people to share with us and say, oh yeah, oh God, that was horrible. Oh, that was great. You know, and imagine if you have somebody that an acquaintance that you're trying to make a friendship with, and every single thing that you like, they hate, and everything you hate, they like. It's going to be very hard to make friends. This is part of human social engagement, is the sharing of attitudes about things. And we're just sharing. The proof of all of this is social media. God, why do people post stuff? Why are you posting it? What goal are you accomplishing when you're posting it? You're sharing with people. You know, it's no fun to do it if you can't share it with other people. This is the strength of our motivation. And here it is at 9 months. This is the same motivation. It just happens to be about something simpler. Okay. And finally, joint attention. This is your classic book reading. This is my daughter on the same day. You can tell she has the same clothes on. And mom is doing the classic book reading and pointing. And importantly, watch where she looks again. So she's going to engage in the book reading. Now she has to look at mom. We're sharing it, you know? And then she actually puts her finger on there and we think she's saying baby. And the sibling is running the camera here. And we thought she said baby, so we were all very excited. But the main point is she's looking back. It's a sharing activity. Now I'm going to show you, this is a little video that lasts a couple of minutes. This is a chimp. I clipped together 3 clips here to try to get her doing something similar to the ball thing and gave her opportunities to communicate and the book reading thing. And you'll see, this is a human raised chimp, about 3 years old. And now, so here's the ball, and the human is pointing to, trying to get the ball. She picks up the ball and bounces it. All right, she reads the engage with the ball. And now you see if the chimp wants to roll it back and forth or engage with it. Not so much. She likes the ball. She likes playing with the ball, but she doesn't want to do it as a shared activity. She wants to do it on her own. Now we're going to do the book reading, and she's interested in the book, and the adult, the human, is pointing it out for her, and she's interested in it, but she doesn't turn around and look. There's no feeling of we're sharing this. We don't have a shared thing going on here. There's no joint attention and common ground in the classic. Yes, it's joint attention in the sense they're both looking at the same thing, but not they're sharing attention to the same thing. And now she'll just rake the book. All right. And so she has opportunity. Now there's another clip. She's going to read the book now. And she has the opportunity to show the way the kid might show you. Oh, look at this picture. Isn't it cool? Look at this, mom. Isn't it funny? And she doesn't care whether the other guy's in the room or not. Now she's got the ball again. Okay, so I'm not claiming any of this is cognitively sophisticated that the child does here. What I'm saying is this is the roots of what is going to enable us to have shared realities, to understand perspectives and roles, and ultimately to scale up to a culture where we have all the shared reality that a culture creates and the different perspectives that go on in there, as well as the normative kinds of attitudes about it. So, so I think this is what I've called the shared intentionality schema, or the dual level structure. This schema is what I think happens at 9 months and starts humans down the road to uniquely human ways of thinking about the world. It's simultaneously, we have shared goal, the joint goal, and joint attention to things. And at the same time, you have your role and I have my perspective. So the blue is the behavior, joint goal, different roles. The green is the cognitive side, joint attention, and different perspectives, right? And this gets us rolling down toward shared realities, perspectives, role categories, cooperative communication, where I'm focused on one thing and I try to get you to focus on it too. If you think about reference, either pointing or with words, but let's stick with pointing because it's easier and it's something chimps could potentially do. What happens? So I, for some reason, am focused on the chair, and for some reason, I want you to focus on the chair. So I have to know that you're not focused on it, because why would I point otherwise? So you're not focused on it, and I get you over here, and so now you are. So I see the relation between our attention. They were not matched, and now you're looking there, they're matched. That's what the act of reference is an invitation to join attention. And if I'm on the comprehension side, you point somewhere, and I kind of, oh gosh, we're not, she wants me to focus somewhere where I'm not. She wants me to join her, and I go over here. And so I know that we're not, and then I know that we are. So joint attention requires a coordination of perspectives, a coordination of, that again, you just don't see in other creatures. And what I'm trying to emphasize to the Cognitive Science Society is that this is not just social. Okay. Yes, it's just social stuff. You say, oh, I'm interested in cognition. This is just how they relate to others. The way they relate to others in this communication and collaboration toward joint goals is going to get you these things: perspectives, role categories, socially recursive inferences. He wants me to think this, or he wants me to know this. Then ultimately, at around 3 to 4 years of age, we scale up to group-minded things, what I call group-minded things, conventions, norms, and institutions, linguistic symbols and constructions. Yes, they're talking before this. That's another issue, but they don't understand them as conventions until they're about 3 years old, that only we do it in our group, and in other groups they do something else. Institutional realities, John Searle, I just saw a YouTube video on John Searle the other day. He always loves to say, this is just a piece of paper, right? Why does this piece of, somebody's going to give me good stuff for this piece of paper, right? And it's because we agree on the value of it and so forth and so on. Somebody's only president because we agree they're president, throwing over, insurrectionist activities left aside. They're only president because we agree they're president. I also think with this comes the distinction between subjective and objective. So this notion of perspectives that started at 9 months, when you get to this group-wide level, it's all these different perspectives. And what our science is based on is that different people have different perspectives, but there is the real objective situation. And that's independent of anybody's particular perspective. Right? Anybody can be wrong anytime. That's the notion of a belief. I myself can be wrong, even though I'm really sure I could be wrong. And if you don't think like that, you're not a scientist, right? So scientists know that something appears, what my subjective perspective is, and what it really is objectively. And I think you could never get there if you didn't have this interpersonal notion of he thinks it's that, I think it's that. Okay, that's where we get to the objective. The philosopher Donald Davidson has a theory like that. And again, I'm repeating myself, but the normative thoughts and attitudes, the oughts and the obligations and stuff. I have a BBS paper on the obligations, I think this comes at 3 to 4 years old. A 1-year-old doesn't have a sense of obligation. By 3 years old, they do. And this normative stuff gets you all the deontic concepts and etc. Just because the theme here is about diversity, I thought I would at least mention that we have a recent study where we looked at this cultural norm enforcement. So one of the pieces of evidence for children having these normative attitudes is when somebody does something against the rules or against the norm, they protest. They say, "No, why are you doing that? No, that's wrong." Right? And so it starts at about age 3, where they will say, "No, you can't do that. It's wrong." And not just morally wrong, but just breaking the rules of the game. So if somebody's playing a game the wrong way, they say, no, you can't do it like that. And we wondered if that was a true cross-culturally, and the answer is it is. In all these different cultures, all the kids, you can see here, one of the kids is playing the game. We have it rigged so that she's playing it in a way that the one sitting and watching thinks is wrong. And so the one who's sitting and thinking intervenes and says, no, that's wrong. You can't play it like that. So they have a sense of right and wrong, even about arbitrary rules, not moral right and wrong, but just rules. And I will say that across the different cultures, they actually did their own enforcement differently, whether it's more verbally or physical intervention or using normative language like wrong and things like that. So there are cross-cultural differences. And I actually think that's the model for a lot of these things I'm talking about is, I think, 1-year-olds are the same the world over, and we have some cross-cultural data on joint attention and pointing and things like that. That's 1-year-olds, 2-year-olds are the same the world over. And then when they get after 3 years old, now the culture can really do its work and you start getting divergences. But on these very basic things that I'm studying, I think everybody has the basics, but then the culture, they come out slightly differently. We have a paper called Fair is Not Fair Everywhere. And it's actually a slight misnomer. We found these kids have a different notion of fairness, but everybody has a notion of fairness, even though it's different in different cultures. So I think that's a model for the most basic processes, is that the foundation is there, and then it gets it undergoes cultural variation later. Okay, so that's basically it. And my conclusion is that cognitive science should pay more attention to evolution and not just the innate modules kind of evolutionary psychology, which I know is the one that has had the highest sort of attention everywhere, but a more organic evolutionary psychology. And cognitive science should pay more attention to the social and cultural dimensions of human cognition. Thank you very much.
Okay, by long-standing tradition, the Rumelhart Prize talk is not followed by Q&A, but by a party where we celebrate the 2022 winner, and we're going to also unveil the 2023 winner. So I'm going to tell you where the party is, but just one last time, let's thank Professor Tomasello for a fantastic talk. Okay, so the Rumelhart Symposium is in this room at 8:30 tomorrow morning. That's a set of talks in honor of this year's prize winner, Professor Tomasello. So put that in your diaries in here, 8:30 tomorrow morning. The reception is in the Soko Ballroom on the 3rd floor of the Delta Hotel. There are at least 15 Delta hotels in Toronto. This has led to much hilarity that I can't tell you about, of people being in the wrong hotel at the wrong time. So we're in the very nearby Delta Hotel. It's on Lower Simcoe Street. You go out the building, you turn right, you'll see a sign that says Lower Simcoe Street, and the Delta Hotel is down there through an underpass. Okay, so 3rd floor of the Delta Hotel, the ballroom there. We'll meet there for a drink and some nibbles, and then the unveiling of the 2023 prize winner. Okay, so see you there.